Hi, I'm Kris Kaczor, and this is Cheatcalls Ethereum Improvement Proposal, an attempt to standardize an interface of Ethereum development nodes. So let me begin by painting a picture of a landscape of Ethereum nodes. So on one end, we have production nodes. So this is your Geth, your Ref, your Aragon, stuff like this. So these nodes are all about strictly, hopefully, strictly following consensus rules of Ethereum. They're about being good citizens in the, between different nodes. So, mining blocks, verifying blocks, gossiping blocks in the peer-to-peer network, stuff like this. And they are totally not about giving developers any control over the state because they need to strictly follow consensus rules. On the other end, we have test environments. These are not really full nodes. They are more focused only on executing EVM code. But so this is Foundry, this is Hardhat, and these solutions are all about giving control to the developers. So here, while you develop your smart contract, you can easily, I don't know, deal ERC20 tokens or Ethereum or Ethereum native currency. You can warp time. You can do things like this, and this is very useful to put put your smart contract in a desired state, so you can test complex scenarios. And somewhere in the middle we have the development nodes. So these are tools like Anvil, part of Foundry, like Hardhat node, like Tenderly or BuildBear. So these development nodes are, on one hand, they are like proper, almost proper Ethereum nodes. So you can ask them about blocks, about logs, and so on and so forth. They implement most of the standard JSON RPC interface. But on the other hand, they also give developers some control over their state. So they have these special JSON RPC methods that allow developers to control them. So let's dive into these development nodes because this is what my presentation is focused on. And turns out they're very useful. So first of all, they support forking. So instead of creating pure empty instance of a node, usually you fork it from some other node, most likely a mainnet node, maybe on a particular block. Another aspect is that they can be both local or running in the cloud. So a good example, basically development nodes shine for all sorts of integration testing when you need to test both your smart contracts and your off-chain system. So for example, in Spark, we simulate every governance spell. We simulate it on a Tenderly fork running in the cloud, and we paste a GitHub comment on a PR with a spell pointing to the UI with this network connected to. So a reviewer of the spell can easily visually inspect the impact of the spell on the UI. Also, we have a lot of end-to-end tests written for our front end using development nodes. And also, we have complex systems balancing liquidity between multiple chains. And guess what? We're also running multiple instances of development nodes running together and acting as a layer 1 and layer 2s. And as I mentioned, development nodes give developers control over their state with these special JSON RPC methods. And let's talk about them. So basically every more complex testing scenario requires developers to basically bypass regular consensus rules. So one of the methods, so let me present some of these special JSON RPC calls. So for example, EVM set next block timestamp allows developers to control the timestamp of a next not yet mined block. You can imagine that this is pretty useful when you need to assert that, I don't know, some exact amount of interests was calculated correctly. Then we have EVM revert, which enables us to revert to previously created snapshot. So it's like a dump of a state at state of the blockchain at a particular moment. Then we have set ERC20 token balance, which does what you expect it to do, or does it? And there's Anvil mine for mining new blocks. And there are many other methods, like really God knows how many, because they are not documented properly. And as you can see, like some of them have different prefixes, but the most important thing is that all of these methods have compatibility issues. For example, EVM set next block timestamp, on some of the implementation, it will actually mine a new block right away, which makes writing deterministic tests impossible. EVM revert, in some of the implementation, it allows you to revert to a snapshot only once, and then the snapshot is like destroyed. Tenderly set ERC20 token balance only exists in like Tenderly and BuildBear. So if you relied on this behavior to mint arbitrary ERC20 tokens and you want to, I don't know, switch to Anvil, guess what? You need to write your own implementation somehow. Anvil mine works great, but only some of the development nodes actually have like a proper mempool, and some others just like automatically mine transactions as they come. So all of these incompatibilities reduce the speed of development and make like basically simple things hard. And this is why we created Cheatcalls Ethereum improvement proposal. It's a standard to be implemented by all these development nodes, by Anvil, Tenderly, BuildBear, and Hardhat. Of course, we're talking with the team to make it happen. But basic idea is that it's like Foundry cheat codes, but for JSON RPC. So this is why it was named Cheatcalls EIP. It's all about like reducing lock-in in a particular node implementation and increasing the interoperability. So imagine that you develop a dApp and you don't develop a dApp specifically for Alchemy or for, I don't know, Infura, right? Like you can switch RPCs without any issues. Guess what? When you're writing these testing scenarios, like the integration tests, you develop it for a particular node right now. And you can think that this is not a huge problem, but turns out that it is, because often you want to switch from local instance to a instance running in the cloud, because, I don't know, you want to have a shareable link with something for everybody. Or you want to use a superior debugging tools that are only available in one of the environments, right? The Cheatcalls EIP is of course like a list of cheat codes that we want these nodes to implement, but it's also a testing suite to verify the conformance to this spec. All of these cheat codes share common prefix called cheat underscore. And just to give you a little bit of taste, like they touch things like time management, mining control, snapshots, impersonation, balance and storage management, and some other areas. So now let me walk you through some of the cheat codes. So time management. As I already mentioned, like this is very useful to be able to calculate interests deterministically and so on. So we have two cheat codes here. Cheat increase time, which mines a new block with a particular timestamp, with a timestamp increased by a particular number of seconds. But I think more useful is cheat set next block timestamp, which doesn't mine a new block, but once the new block is mined, it's gonna have like an exact timestamp. And guess what? Like this is properly specified, and we have proper tests to catch all these mistakes that happened in some of the implementations. Then we have mining control. So in Cheatcalls, we have a proper mempool. And first of all, you can just mine empty blocks with cheat mine. But I think the more interesting is cheat mining mode, which enables you to set one of few mining modes. Like, for example, the default is auto. So basically, as transactions come, the new blocks will be mined. But you can set it to manual to basically stop block production, and you will be required to use cheat mine to mine new blocks, and all the transactions that are going to send are going to be inserted into mempool. And there's also like interval mining, so something that we're used to when dealing with mainnet. And speaking about mempool, we have control how the block production chooses transactions from the mempool. It could be random, it could be like, highest fee first, or first in, first out. And also we have control of dropping the transactions from the mempool. So all of these methods allow you to test complex block submission systems where you can simulate reorgs, you can simulate drop transactions from the mempool, and so on and so forth. Then we have a bunch of cheat calls regarding snapshots. So cheat snapshot creates a snapshot, and then we have cheat revert snapshot, which reverts to the previously created snapshot. And of course, we make sure that you can revert to a given snapshot multiple times. Impersonation is quite important because often you want to impersonate an account that you don't hold a private key of. So for example, imagine that you want to push a Oracle update, but obviously you won't have a private key to of the Oracle. So you can impersonate an account of an owner of the Oracle and push an update. And if you're familiar with the previous implementation, you were able to either impersonate a single account or sometimes impersonate all of them at once. So we opt into just impersonating every account automatically. So this is what cheat impersonate all accounts does. And you have control either you use impersonation or not, because your client library, if you provide a private key, they're going to automatically use if send raw transaction. So you send a signed transaction to the node. And if you don't have a private key, just an address, the libraries are going to use if send transaction, which contains all the information about the transaction, and node actually like signs it or just pretends that that they are signed. We also created a meta cheat call for inspecting the current state of the node. So by calling cheat info, you get a bunch of this basic information about the state of different cheat calls, like what's the mining mode, what's the state of impersonation, and so on and so forth. And also it returns you a cheat code spec version. So this is to future-proof this proposal when there will be probably more proposals extending it. Now let's talk about balance and storage management, because this is one of the most important things that you will likely do on development nodes. So cheat set balance enables us to set a balance of a native token, but cheat set ERC20 token balance does the same for arbitrary ERC20 tokens. And this is best effort implementation, because ERC20 token standard doesn't talk about how to mine tokens and so on. So you cannot do it in every single case, but we can actually come up with an approach that works most of the times, and I'm going to talk about it in a second. Finally, we have cheat set storage at, which enables us to set a particular storage slot of a particular account. So how does setting a particular ERC20 token balance could work? So with cheat set storage add, we can set arbitrary storage slot. The problem is that we don't know which storage slot holds a value, holds the balance of a particular account. So just a reminder, EVM storage is like a huge uint 256 to uint 256 map scoped for each contract. And Solidity storage layout says more or less that each property gets an index, and if the property is a mapping, then to find the storage slot, you actually take an index and you take the value of the key, the key, and you hash them, and this is your storage slot. So we can actually set arbitrary storage, arbitrary ERC20 token balances by tracing the balance of call for a particular account first, and then we can basically, iterate over touched storage slots and change them until we find the one that holds a proper balance. And this is actually how Forge STD deal cheat code works under the hood. So this implementation is pretty good. It works with most ERC20 token implementations. And if you're doing something very custom, you probably want to come up with your own mock for a given contract or something like this. So what's the state of this EIP? So it's in pre-draft state, meaning that it's submitted to Ethereum magicians, but it's not yet submitted to the EIP repository. There are 3 contributors, 2 contributors other than me, so special thanks for Piotr Szlachciak and Emmanuel Antony for helping me with this proposal. And all the teams of developing the nodes are already familiar with the spec, and we're talking with them, and even today we had a pretty good discussion, tweaking some of the behavior. And here's a QR code for the 2 Ethereum Magicians forum, and you're all invited to contribute, comment, and so on. And also, I'm more than aware that pushing standards in the industry is not necessarily easy thing to do, and there's this obligatory KXCD comic strip saying like, oh, there are 14 competing standards. It's ridiculous. We need to create another one that is universal. And guess what? There are 15 competing standards now. So luckily, in this case, we don't have any competing standards. It's just something that wasn't standardized ever. So I hope we will have a better time doing that. But I'm also I'm also aware that it can take some time for teams to implement it. And there's this alternative client-side approach where we can emulate and try to smooth out some rough edges on the client side. So this would be best effort implementation. Some of the things won't work because it's just impossible to do it client side. But we can document actually what's possible, what's not. We can warn users about incompatibilities. And actually, one of the more complex cheat codes like set ERC20 token balance, actually, it can be implemented client-side because you can trace any call using access lists. So it's possible to implement such thing, for example, client-side. And we actually have internally a prototype of this approach, and it's something that might help with transitioning for the full proposal. And that would be it. Thank you, guys. And here's a QR code to the spec again. And as I said, you're all invited to contribute, and I can't wait to hear your comments and opinions. Thank you.
Kris, great job. Great presentation. Thanks so much. So with that, remember, you can scan the QR code. You can submit your questions. Yeah, I see some hearts. Someone is loving the questions and the presentation. And you can also vote for the questions that you like the most. So let's start with the top one. When impersonating, what does EC recover do? I'm thinking about use case like permit to.
Yes, so this is something that we decided not to tackle yet. This is a known problem, like it also doesn't work right now. What my suggestion is that if you need a signature, most likely the address of the account that you need the signature of is somewhere in the EVM storage of the contract. So what you can do is you can override the storage slot with an address of a you know that you know the private key of. So this way you just bypass this problem and you don't use impersonation at all. You just set storage slot.
Great. The next one is, can we have a cheat mining mode where timestamps do not increase automatically at all?
Timestamps of the blocks, right? Yeah, I think it might be a good idea because actually it's a problem that they are picked automatically, and yeah, I agree. This might be a good idea to just, I don't know, crash instead of mine a new block, and then you would need to set the timestamp of a block explicitly before. So yeah, I definitely think it makes definitely sense. So thanks for this comment.
And whoever did it, or if you guys have other ideas, please find Kris after the talk. I think he will appreciate that. What about the get storage range, or even the get all storage of a contract? Helpful to match the state against an expected snapshot after every action, test action.
Yes, this is great question because iterating over storage slots is like a particularly difficult problem to deal with. So this is like a first version of the spec, and I expect there will be more. And maybe this is one of the problems that can be tackled in the future. One of the like guiding principles of writing EIPs is to keep them focused. So I explicitly wanted not to deal with too many problems at once, but I think like this would be an interesting challenge to tackle. And some of the nodes like Aragon have some special methods to iterate over the storage slots.
Right, but yeah, scope creep is a real issue on engineering. Okay, wouldn't impersonate all hide bugs about misuse of certain private keys?
Yes, so I don't think so. In my experience, like it's much useful to use impersonate all than worrying about, oh, did I impersonate the particular account or not. As I said, like this should be dealt private client side, right? Like if you don't want to impersonate an account, you shouldn't have private key of this account lying somewhere in the client library. This is my current view on this thing. I was also thinking about that maybe it's a little bit too much, but talk to me. I'm open to any suggestions, and like Ethereum Magicians is like, I guess, the perfect place to leave such comments. Or you can talk to me here.
Yeah, we need more and more reviewers, more ideas. All right, can we have a cheat restart node to clean up state and cheat revert state to recover state?
Yeah, so Anvil, I think, has something along these lines. The problem the problem why it's not currently part of the spec is that the spec has to be like universal and has to work with the nodes running in the cloud as well as like running locally, and this doesn't really make sense for the ones running in the cloud. Like I think Anvil calls it EVM or Anvil reset. So it's possible to do. I'm just not sure if it should be part of the standard, right?
Yeah, I think that was the last one. Again, wanted to thank you. Great presentation, great questions, and please give a round of applause. Thank you, Kris.